Evolution of gas, a characteristic of chemical reactions. So we all know that reactants, they are converted into new substances called as products. So when reactants are converted into products, we observe certain changes which are observable changes that takes place in a chemical reaction. So when observable changes takes place in a chemical reaction, it is known as the characteristic of chemical reaction. So the main characteristic of chemical reaction is evolution of gas. We'll study about this through an example. First, in this diagram we can see that they have taken a conical flask, they have added zinc granules to it, and then later we have to add dilute sulfuric acid, which is dilute H2SO4. What happens when we add dilute H2SO4 to the zinc granules? Bubbles of hydrogen gas is evolved. Okay, so when zinc granules react with dilute sulfuric acid, dilute H2SO4, then bubbles of hydrogen gas are produced. We'll write this in the form of chemical equation. Zinc, which is in solid state, reacts with H2SO4, sulfuric acid, which is in aqueous state, which means that it is mixed with water. It gives rise to zinc sulfate, which is also in aqueous state, plus H2, hydrogen gas, which is in gaseous state. So this symbol here represents that this particular gas is evolved during this chemical reaction. So zinc here is a metal which reacts with sulfuric acid to give metal sulfate and hydrogen gas. So how do we perform it in laboratory? How do we perform this in the laboratory? First we have to take a clean conical flask, we have to add few zinc granules in it, then we have to slowly add the dilute sulfuric acid to that zinc granules, and then what will we observe? We will be observing that a gas, hydrogen gas, is evolved during this chemical reaction. In this chemical reaction, which gas is evolved? Hydrogen gas is evolved during this chemical reaction. And what is the observable change we have noticed here? That the flask, when we touch the conical flask, when we touch the bottom of the conical flask, it will be hot, it will be somewhat hot. So is change in temperature observed in this chemical reaction? Yes, change in temperature is observed in this reaction, which means that this particular reaction where zinc reacts with dilute sulfuric acid to give metal sulfate, zinc sulfate and hydrogen gas, this is an exothermic reaction. What is an exothermic reaction? Heat is evolved, heat is released during this reaction. So this reaction is also an exothermic reaction, and we have seen hydrogen gases evolved here. Now other examples for evolution of gases. First example here is magnesium reacts with dilute sulfuric acid to give magnesium sulfate plus hydrogen gas. So this is a word equation. We have to convert this word equation into a chemical equation where we will be using the formula of all these compounds. Okay, so first magnesium Mg plus dilute sulfuric acid is H2SO4, which gives rise to magnesium sulfate MgSO4 plus H2. So we can correlate this equation with this reaction. See here, metal, we have taken zinc metal, here we have taken magnesium, which is also a metal. This is reacting with dilute sulfuric acid, here also it is reacting with dilute sulfuric acid, and when metal reacts with dilute sulfuric acid, it gives us metal sulfate. So what is the metal here? Magnesium. So what will be the product? Magnesium sulfate, metal sulfate, magnesium sulfate, MgSO4, plus which gas is evolved here? Hydrogen gas is evolved. So this is also an example for evolution of gas. Now second example is magnesium reacts with HCl, metal reacts with hydrochloric acid, dilute hydrochloric acid, which gives us salt, MgCl2, magnesium chloride, and even here hydrogen gas is evolved. So this is also an example for evolution of gas. Now the third example is little bit different, because in all this we have seen metal is reacting with an acid to give, here we have seen a metal sulfate, and there we have seen a salt. Okay, and at last we have seen the evolution of hydrogen gas. But in this particular example, we are taking metal carbonate, sodium carbonate, metal carbonate, okay, which is sodium carbonate, is reacting with HCl, hydrochloric acid. See, dilute hydrochloric acid is poured over sodium carbonate in a test tube, then carbon dioxide gas is evolved. In all these three examples, we have seen the evolution of hydrogen gas, but in this example, we can see the evolution of carbon dioxide gas. So, when metal carbonate, which is sodium carbonate, when it reacts with HCl, hydrochloric acid, it gives us salt, sodium chloride, salt, plus water plus carbon dioxide gas is evolved. So, here metal carbonate, sodium carbonate is in solid state, HCl is in aqueous state because it is mixed with water, hence its physical state is aqueous. They both react to give sodium chloride, which is a salt, and it is also in aqueous state, plus water, which is in liquid state, plus carbon dioxide gas, obviously it is in gaseous state, and this carbon dioxide gas is evolved. So, this example is also related with this evolution of gas.